Welcome to Weighing, Measuring, and Making Solutions by Amino Labs. The first thing we're going to look at is unit prefixes. Unit prefixes are a simpler way to describe orders of magnitude. There's a good chance you've been using these throughout your scientific endeavors, your classes, but we're just going to dive a little deeper in here just to make sure there's clarity, because as we get into the next sections and do examples, prefixes are going to come up a lot. So you're aware that units are systems of measurement. And so units could be grams, liters, if you're talking about mass or volume. If you're talking about distance, you've got meters, right? So there's a number of different units that are typically used in science. And prefixes are added onto the beginning of these unit words to give context about how much is there, and often to better communicate how much is there. So these prefixes include kilo, milli, micro, nano, pico, right? There's a lot of different ones here on the table on the right. However, you'll see that next to these orange arrows are the most widely used prefixes in life science. Okay, so we've got kilo, we've got milli, we've got micro, and we've got nano. Pico is used a reasonable amount in life science, but not so common. Okay. Now, prefixes, you might be aware, help to describe and establish orders of magnitude, okay, or power factors. So you can see these are the power factors. We've got 1, 10, 100, 1,000, et cetera, million, and so on and so forth, right? And so these prefixes help to simplify how to explain something that is like 1/1,000,000th times smaller than a unit, right? And so on the bottom here, just as a quick example, a milli is 0.001 of something, or 1/1000th of something. So you could say 0.001 grams is a milligram. And with the abbreviation, you can see the symbols here. These help to know what letter or symbol you put in front of that unit. So this is how you would write 1 milligram. It would be with a small m, which we see here, and then G is for gram. Let's look at an example here with mass. Okay, the orange arrow highlighted unit prefixes, you might have noticed, are 1,000 times separated from one another. So if we've got the base unit here, where in this example we've got a gram on the left here, so that's the base unit. A kilogram is 1,000 times larger than 1 gram. Conversely, a milligram is 10 to the minus 3, or 0.001 times smaller than a gram. That's 1,000 times smaller. We then have a microgram, which is yet another 1,000 times smaller. Okay, so that's 1,000 times smaller than a milligram, or 1,000,000 times smaller than a gram. And then we've got a nanogram, which is yet another 1,000 times smaller. So it's 1,000 times smaller than a microgram, 1,000,000 times smaller than a milligram, and 1,000,000,000 times smaller than a gram. Right? Specifically looking at the microgram here, you'll see the Greek mu is used to describe micro. However, if you can't find that, often a small lowercase u is used. Okay, so this is a small UG. And sometimes you'll also see an MCG on a label to describe what a microgram is. Okay, but if you can, try and use the Greek mu. That's the most scientific, and that's it's the common standard. Okay. If we use liters as a measurement of volume, which is very common in life science, we have a liter, and 1,000 times smaller than that, 0.01, is the milliliter. You could also say 1,000 milliliters equals a liter. If we go down even further, 3 orders of magnitude, or 1,000 times smaller, we get to the microliter, which is 0.000001 liters. So you could say 1,000,000 microliters equals a liter, and 1,000 times smaller, the nanoliter is 0.000000001 liters. So you could say that 1 billion nanoliters equals a liter. Okay? So getting quite familiar with using these terms is essential for the lab in communicating to others and having them communicate to you. You might have somebody say, hey, can you make me a concentration of 10 nanograms per microliter of DNA? And you need to know what that means. So it's really important to pick this up. And this language, this is just normal part of life. You're always learning language as you're growing and studying more. And science has a language of its own, science and engineering, right? So you just pick these things up along the way. Now, one thing to mention is often these prefixes are employed to use whole numbers of something. So often you'll have a whole number that's ahead of the unit and the prefix, and that's actually one of the reasons you use prefixes. So rather than saying, oh, I've got 0.001 grams of this, it's kind of a bit confusing, and it's hard to really kind of like gauge how much that is. But once you get used to this system, you could say I've got 1 milligram of something. So it's a little bit easier to communicate, or I've got 10 milligrams or 53 milligrams is a lot easier than I've got 0.053 grams, right? Especially if you're working at very small numbers like in the nano and the micro or even the pico, to say I've got 0.000000023 grams. It's easier to say, I don't even remember how many zeros that was, but it's easier to say I've got 23 nanograms, right? So it's a big part of this is just about science communication and being able to gain context about how much is there through using the prefixes. Another point here is when you're writing units next to the number of units, it's important to put a space in between. Okay, so this is just a really good practice to have for communicating science. So you don't want to have just the milligram cozied up to the 10 here. You want to have a space there. And this is universal. Whenever you're writing any unit of measurement next to a value, you always want to have a space. Okay. All right, so if you're in the USA or another country that uses the imperial system, apologies, but also I see this as a way to grow and expand and learn. You might be used to feet and pounds and gallons and ounces, I guess. But in the world of science and engineering, we use the metric system. So it's just, again, a normal part of entering a professional world that uses the metric system. And so, yeah, one of the next steps that you can do here is there are a couple of activities that are created to practice this. One is to look into your environment, maybe at home or somewhere else, and try to find some of these unit prefixes and describe how much of it is there. Right? So this is a way to practice it. And in a second activity, you're able to convert measures and match up some unit prefixes. So happy learning of prefixes. And I know this is going to help you advance your skills and your ability to communicate in the lab.